Yes, good morning, one and all. Okay, today in the last class we are discussed about ADD steps. There is a methodology to design a particular software architecture. So this architecture is mainly focusing on how we can concentrate, how we can provide better quality requirements and functional requirements, how we can combine both these quality and functional requirement to shape the particular software architecture. So we want to shape the perfect software architecture. So we are using one of the better approach or model rather than the previous like waterfall model and so on. So we are using ADD method or approach. So that is called attribute driven design method. Okay, now in this we are following some sequence of steps. So I recall you what are the steps we are explained in the last class with the real time example of garbage door system. Okay, na? So home information system. For raising and lowering the garbage doors. Okay. So here just I want to say the steps what we are discussed in the previous class to ADD method, how we can design the software architecture to the particular software system. Okay, so this is the first step is choose the module to decompose. Okay, na break the content, break the entire the project or program into sub modules first. Okay, na that is these are the different types of decompositions, system or subsystem and sub modules. Okay, na the first we can overview on system, then the system is going to divide into subsystems. The subsystems are going to again divided into the another pieces or modules that are called sub modules. Okay, and also we can view the second point, that is called choose the architectural drivers. Choose the architectural drivers. Here the architectural drivers is nothing but the combination of functional and quality requirements. Why? Because as I said in the previous, that shapes the architecture or to the particular module under consideration. So entire the architecture ni manam shape cheyadaniki gaani lepothe particular module ni manam shape cheyadaniki gaani we want to combine the functional and quality requirements. So these are the main drivers for software architecture. Okay, now these are mainly focusing on top down priority requirements. Okay, now of a particular modules. That is the second point. First point, choose the modules to decompose. Second point, choose the architectural drivers. In this we are having another sub points. First one is that is choose an architectural patterns. Okay, now first we can select the requirements what we collect, what are the requirements we are collected. So among the functional and quality, so among that we are going to choose the particular pattern. So according to these particular requirements related to the different types of stakeholder concerns. So these are the requirements. Based on these requirements, so which type of architectural styles, patterns are nothing but styles we can use. Okay, we can pick one better style or architecture. Based on that we have to design. So first we have to choose an architectural pattern. This according to this use cases, this is class diagram actually. It's represented the garage door drivers. So how we are going to interface this particular virtual machine. So what are the different types of problems are occurred, which type of guidelines it is going to give. So when the problems is obstacles is come, how we are going to overcome them. So these are critical situation how we are handling. So how when the system is again going to restart in a particular seconds of time, these all are considered in this particular style. Again also we can use the first level decomposition of first level means the system wise or subsystem wise or module wise. So when you are going to decompose, okay na, so first we can view the things. Okay, na a diagnosis, how we are using the interfaces to the particular car raising and lowering system, how the home person, who is a person is going to operate, how is interact with the particular virtual machine, how the virtual machine is communicate with the particular architecture. This everything is going to this, how the abstracts are going to be recovered. So what, how which type of schedules we are going to give the grant in the deadlines and all. So like this, based on this consideration, so we have to choose the patterns. So like this we are going to design, so according to the requirements. So what are the requirements they are having, to the particular concerns of the users. So we, by considering the requirements, based on that they will satisfy the both quality and functional requirements. That's why they are going to combine both. So after combining them, which type of styles we are using to design this. So in this, while designing this, we need to focus on different types of stages. Okay na? So like this we are going to design. Then request the architecture with views. Okay, now we are having different types of architectures we are going to represent. Already I told this, I explained this part also. Module decomposition views and concurrency views. Okay, now so module decomposition views means so the users doing similar things at the same time. Okay, in this case the abstracts are come will become. So how we are going to solve them? Okay, na? Either multitasking or like for the parallel communication or sequential communication. So the different types of communications or interfaces we are going to maintain. Okay, here. So again, another reason also there. One user performing multiple activities simultaneously. Different users same time low use చేయడం is a one procedure. Same person is going to perform multiple actions simultaneously, means sometimes we are doing programs. So while doing programs, or means while writing programs or while executing programs, so we are somebody, for example, somebody want to listen the music, so somebody want to view the videos and all. So multiple tasks are going on, so okay, by the same person. So in this situation, so also it is flexible to provide this. Okay, na? Like this, by viewing those all scenarios, based on this, if the system is going to be, the architecture is going to be designed. ఓకే, అంటే ఏంటి ఇక్కడ మల్టిపుల్ యూజర్స్ సేమ్ టైమ్ వర్క్ చేస్తే వచ్చే ప్రాబ్లమ్స్, అబ్స్ట్రాకిల్స్, హౌ వీఆర్ ఓవర్కమ్ దెమ్. Otherwise or so same person is doing multiple activities simultaneously. In this situation, how we are going to get the problems, how to resolve them, like based on the thinking of the background, so of the particular content, so according to that they are going to design the software architecture. That is the main thing. Next, how when starting of the system, so load అవ్వాలి కదా, starting of the system and booting is going to take place there, shutdowning the system. So these are all the things we are having in this, these all views we have to concern while designing the architecture. So while thinking that which type of problems will be occurred, so based on that also we they are going to design the systems either simultaneously or parallelly. They are going to design the system to multitasking or multi-threading. So next, defining interfaces of the child modules. Okay na? So we are also providing the interfaces to the child modules. So child modules means what? The subsystem having another internal modules, the main system having submodules, but submodules are furtherly going to divide into child modules. Okay na? So for this each piece of the particular system, it's having the internal relationship that is called interface. Okay na? They are also focusing on the particular interface, step by step procedure. It's how they are going to communicate together, vice versa. So and also they are mainly focusing on concurrency view documents. Okay na? So and also they are focusing on development view documents. And the final fifth step in the second point, the verify and refine use cases and quality scenarios as constraints for the child modules. Okay, just we can refine the use cases always. The use cases is mainly to interact, to design the systems. First, use case diagrams are very important. Okay, now so always we can refine them. Okay, now so based on this modifications, we can refine first the use cases and use cases scenarios and quality scenarios. Based on this, the quality scenarios is always be going to be changed. And also in this mainly we can focusing on functional requirements. So what are the functional requirements? User interfaces, according to our example, raising and lowering door module and abstract detection, communication, virtual machine and scenario sensor or actuator, virtual machines and scheduler and diagnosis. These all points we can view here in this. Okay, now user interfaces, we can focus on user interfaces, raising and lowering the door modules and abstract detections, communication, virtual machines and so on. Okay, now in this phase we can focusing on these type of particular functional requirements. Again, constraints. Okay, now we can follow the different types of constraints. The decomposition satisfies the constraint. The constraint is satisfied by a single child module. The constraint is satisfied by multiple child module. Okay, now so according to that constraints, so these can be satisfied by the decomposition first. So these constraints are satisfied by the single module and also multiple modules, and individually initially it is single modules. When you are going to combine together one by one, so those are the multiple modules. So based on single module it will be going to good, and also when we are combined these multiple modules, in this case also it will be going to good based on these constraints. So we are going to be make the particular system. And quality scenarios, the quality is very important according to the like functional requirements. So the quality scenario may be completely satisfied by the decomposition without any additional impact. That is the first point. And second point, a quality scenario may be satisfied by the current decomposition with the constraints on child modules. And the third point, the decomposition may be neutral with respect to quality scenarios. So a quality scenario may not be satisfiable with the current decomposition. So we can view these all quality scenarios also, along with constraints, along with functional requirements, along with quality requirements. We need to questioning interself. Based on that, they are going to design the particular architecture. Then next concept, up to the ADD steps are end. Next concept, forming the team structure. Forming the team structure. Here, who is that? What is the meaning of team? Team is nothing but is a group of members. Group of members. Here, forming the team structure means for what? For software architecture design. So already the software architecture is going to be designed like this. We are going to design, we need to follow this type of requirements, we need to consider these types of concerns, we need to focus on quality requirements and functional requirements and all. Based on this, they are going to be design the software architecture. So once they are fixed to design the software architecture, so they design. So after what they are going to do? So therefore they are forming the team structures. They are forming team structures. Here the team is the group of members. So they are forming the structure to the particular team. So that is the meaning of forming the team structure. So once the first view levels of the architecture's module decomposition structures are fairly stable, those modules can be allocated to development teams. సో ఒకసారి మనకి డికంపోజిషన్ అయిపోయి ఆర్కిటెక్చర్ మాడ్యూల్స్ డికంపోజిషన్ స్ట్రక్చర్స్ అనేవి జరిగి ఓకేనా. సో దెన్ దే విల్ బి గోయింగ్ టు అలాటెడ్ టు ద పర్టికులర్ డెవలప్మెంట్ టీమ్స్. ఓకేనా, దీస్ ఆర్ ద డెవలప్మెంట్ టీమ్స్, ద teams here, development teams. Okay, now this view will either allocate modules to existing development units or define new ones. సో ఆల్రెడీ ఉన్న ఎగ్జిస్టింగ్ మాడ్యూల్స్ అయినా కానీ లేకపోతే దే ఆర్ గోయింగ్ టు డిజైన్ న్యూ వన్స్, ఓకేనా. సో దే విల్ బి గోయింగ్ టు అలాటెడ్, దీస్ డిజైన్ టీమ్స్ ఆర్ గోయింగ్ టు అలాటెడ్ for existing development units or define new ones, whatever it may be. So suppose you have to consider how they are going to, how the team is going to communicate together, as how they are maintaining the channel between them. Why? Because they are dividing the entire thing into sub modules, okay na. Each and everyone is given to the particular team member, okay na. But every module having interrelationships in, they are maintaining interfaces, okay na. So for this they are going to be communicate through via. So some here we need to take one example. So take any two nodes. Suppose we are taking any two nodes from starting node or ending node, whatever two nodes we can take, either source or destination, whatever it may be, two nodes. For example, X and Y of the system. Either they are joined by a branch or not yet. So how they are going to join? By their branch, any channel or not yet. This is either may communicate with each other in some way meaningful to the operation of the system, they do not. Okay, if there is a branch, suppose if there is a branch, then the two design groups X and Y which design the two nodes must have negotiated and agreed upon the interface specification to permit communication between the two corresponding nodes of the design organization. So these are the two different design groups, okay now, which designing the two nodes, okay now, must have negotiated and agreed upon the interface specification to permit the communication between the two corresponding nodes, okay now. They will be take an decision or agreed to make the specific communication is going to be permit in between the two corresponding nodes of the design organization. If on the other hand, ఒకవేళ if there is a branch అనుకున్నట్లయితే, if another hand there is no branch, ఒకవేళ ఆ బ్రాంచ్ కమ్యూనికేషన్ లేదు, what will be happens, okay na, branch between X and Y, X is the one team and Y is the another team, then the subsystem do not communicate with each other. So if it is a, if it is there is no branch to communicate communication between to provide the communication between X team bit and Y team. So in this situation there is no intercommunication or interface between the submodules. ఓకే అంటే టూ థింగ్స్, అంటే కమ్యూనికేషన్ ప్రొవైడ్ చేసేయాలి అంటే వాట్ వీఆర్ గోయింగ్ టు డూ. సో ఇఫ్స్ నాట్, వాట్ ఆర్ ద ప్రాబ్లమ్స్ విల్ బి అక్కర్డ్. సో వైల్ డెవలపింగ్ దిస్ పర్టికులర్ ఆర్కిటెక్చర్ బై ద టీమ్స్, so they also again thinking internally, so how they are going to communicate together, so which type of communication channel they are using in between different nodes is nothing but these are related to the teams, okay na. So that is the thing. If they are not, the subsystems do not communicate with each other, there was nothing for two corresponding design groups to negotiate. ఇలాంటి సమయంలో there is no different groups are not required, and therefore there is no branch between X and Y. So in this situation we are not required two different teams, so for X team, for Y team. So why? Because they are not communicate with each other, so there is no branch. So like this we are, and how many teams we required, how to forming the teams. So like this they are going to be forming the team structures, okay. Here we need to see, so Conway was describing how to discrete or organizational structures from system structures, but the relationship between organizational and system structure is bidirectional and necessarily so. So here we need to consider two things. So one is the system structure. So we are following one skeleton system like this, we are going to design, we are going to develop one skeletal system that is a blueprint to the particular structure. So as well as this is the relationship between organizational, okay na. So here in the organizational is mainly focusing on employment. So the employees are the main source in this organization, they are going to be develop the particular structures. So they are having some teams, employee teams. So that's why these are also having the communication between bidirectional, means together. Okay, vice versa. That is called bidirectional. So between organizational and system structures, that is very necessary. Okay, now the impact of an architecture on a development of organizational structure is clear. Once very the main role is placed by the organizational structure, that is very clear. Once the architecture for the system under construction has been agreed on, teams are allocated to work on the major modules and a work breakdown structure is created that reflects those teams. Okay, so ఒకసారి అగ్రిమెంట్ అనేది కుదిరిన తర్వాత ఏదైనా ఒక క్లయింట్ అగ్రిమెంట్ కుదిరిన తర్వాత సో the entire they are going to decide, they are going to decide to develop the particular software system. So in this case, when they are agreed to develop or to construct the system, so the teams are allocated to work on the major modules. Okay, so the major modules, okay, the entire the system is going to divide into some modules. Okay, now each one is called as a treated as a one major module and works breakdown. Okay, and also meanwhile the work is going to break down, is created to reflect some those teams. Okay, then the work is the whatever the major modules they are going to divide, those major modules are assigned to the particular team members. Okay, na particular team members. Okay, na to develop a particular system. Next, each team then creates its own internal work practice. Okay, a system-wide set of practices in adopted. So for large system, the teams may belongs to different sub-constructors. Okay, then when the modules are divided, these modules are allotted to the team members. So then when they are allotted the modules to the team members, each team then creates its own internal work practice. Okay, now they can be create their own internal work practice. The work practices may include items such as bulletin boards and web pages for communication, naming conventions for files, and the configuration control systems. So first వాళ్ళు చేసే టాస్క్ ఏంటి after allotting the work to them. So first they were to practice may include items such as bulletin board. Bulletin board means what ma? Information board. Okay na, everything మనకి ఏదైనా ప్రాబ్లం అక్కడ అయింది అంటే మనకి మెసేజ్ రావాలి. ఓకేనా, లేదు మనం ఏదైనా ఒక క్వెరీ ఇచ్చాము అంటే దానికి తగ్గట్టుగా మనకి రిప్లై రావాలి. సో దట్ ఈస్ కాల్డ్ బులెటిన్ బోర్డ్. ఇన్ఫర్మేషన్ మెయింటెనెన్స్ సిస్టమ్ ఈస్ కాల్డ్ బులెటిన్ బోర్డ్. Okay, now then web pages for communication, and also they can create their own web pages for communication and as well as for report generation also, naming conventions for files and the configuration control system. Everything will be the first they can be choose the work according to the particular themes after assigning the modules to work them. So all of these may differ from group to group. So every group is differ together. So again, especially for large systems, okay na, first we are going to develop the large systems. So each team having their own perspectives, then they are combined later. That is another issue. Okay na. Are you hearing me, ma? Lavanya, are you hearing me? Lavanya.
Yes, ma'am. Yes,
ఓకే
ma'am.
ఇక్కడ ఎస్ మా ఇక్కడ జేఈఎం ఎగ్జామ్ది ఉందంట సండే ఏదో వర్క్ జరుగుతుంది నెట్ కూడా ఆపేస్తారంట ఈ 10 minutesలో ఓకేనా
Okay.
నేను అటెండెన్స్ తీసుకొని సెషన్ క్లోజ్ చేస్తాను అలాగే ఉండండి నెట్ నెట్ ఏదో సెట్ చేస్తున్నారు నెట్ ఆపేస్తారంట Okay, so our current topic is forming the team structures. Once the design is going to fixed like this, we are going to design based on this. This work is assigned to the team members. Okay, now while assigning to the team members, the entire thing is going to divide into modules. So these modules, major modules, going to divide into major modules. These modules assigned to the particular team members. Okay, na? So they are also, these team members are also having internal relation. They are also having to communicate together while working. So first individually they are working according to their modules. So then they are going to interface these modules. That's why they need to communicate together while interface the particular modules. So that is the main importance of the forming the team structure. Why the organization forming the team structures? Okay, na? So here we need to consider how much importance they are given to develop the particular software architecture, as well as they are also focusing on the organizational structure. Here the organizational structure is nothing but employees mainly. So those are here we can consider those are the nothing but teams. Those are nothing but teams. Here we need to take two hands. So both are when we combine both hands, then we get the sound like this. When the team structure is perfect, when the organizational structure is perfect, so automatically they will develop the particular architectures and according to the designs. Okay, now that is very important. Here we need to in this architectural development, mainly they can consider the two sides, either organizational side and this development side. Okay, that is very important. Based on the consideration, they are developing the particular software architectures for a particular fundamental software structures. So that's why they are given more importance to forming the teams. Okay, na? The team members, they can share the works together. So somebody is focusing on some work, somebody are mainly focusing on coding side, somebody are documenting side, and all everything will be a structure they are putting in the form of structure. That is the team structure. And also they are mainly focusing on work practices may include the items such as bulletin boards, web pages, communications, naming conversions or files, and configuration control systems. Mainly they are focusing on them. And also they may different from different groups together, again especially for large systems. Okay, now further more quality assurance and testing procedures are set up for each group. Okay, na? So and each group needs to establish and coordinates with the other groups, as I said. So each group can work together and according to their individual, then they need to communicate according to the particular groups with other groups. And thus the teams within a organization works on modules. Within the teams they need to high bandwidth communication. So definitely they need to maintain high bandwidth communication. So my high interfacing, that is a bandwidth is nothing but it's a networking actually, but they are not, they are maintaining the good communication, high bandwidth communication. So much information in the form of detailed design decisions is being constantly shared. So apart from the detailed design, design is the one thing, detailed design is the another thing. So first they can design, when they are going to finalize that, that is called detailed design. So when they are taking the step for detailed design, in this situation they need to communicate frequently in the form of high bandwidth communication. So for take the detailed design decisions. Why they need to communicate together, so in highly means they need to take the good decisions. So which decisions? Design decisions is being constantly shared. So about design decisions they need to share in between them. So that's why they need to communicate together in the form of high bandwidth communication. Okay now, so between teams low bandwidth communication are sufficient and in fact crucial. So low bandwidth communication is sufficient, but sometimes it is give some problems. Okay now, that's why they need to mutually communicate together. That is the meaning of it while designing this particular developing particular architectures. Why? Because they need to share their design views, ideas, whatever it may be. So that is another main important regarding to the why they are organization forming the teams. Okay, high complex systems result when these design criteria are not met. In fact, structures and controlling team interactions of turn out of the important factors affecting a large product success. So according to these, whatever the large, so small projects and they are not taken this much of discussion. Okay, na? But they are not concentrating on this much. Okay, na? They require some little bit of employees, but they are doing large type of systems. They are doing large type of designing the particular systems. In this situation, it can be impact on the particular success of the project, large project success. If interactions between the teams need to be complex, so either the interactions among the elements they are creating are needlessly complex, or the requirements of those elements were not sufficiently hardened before developing commenced. Okay na? So according to this, these points the teams going to be interact between them. So in this case, there is a need for high bandwidth connection between teams. In this situation, according to that scenario, they required high bandwidth connections between them, not just within teams, not only for teams like according to this communication, requiring substantial negotiations and often rework of elements and their interfaces. So sometimes they need to change the elements, means components. So in this case, how they are going to change them? So according to the existing one, without affecting that, they need to update the new things. So in this situation, this is the very important in the designing. The existing is not affected by design in the case of redesigning. So whatever the existing thing, it is not affected by the embed the interface with the new thing. That is very crucial point here. So according to the elements and their interfaces, like software systems, teams should strive for loose coupling and high cohesion. So according to you need to design an architecture. So mainly we are having different types of possibilities: no coupling, loose coupling, tightly coupling, and fully coupling. So we need to acquire some features. We are not acquiring the other features. First of all, that is a no coupling. We will acquire some features to integrate. That is a loose coupling. So and tight coupling, most of the 75% of features we need to acquire for existing. So that is the thing. And tightly coupling, we need to completely integrate two different mechanisms in at a place. So that is the another thing. According to the couplings also, they are going to design the structure. That is very important. While designing, while developing this, they are going to choose so which type of couplings they are using in, especially in the designing of software systems. Okay, this module is user interface layer of the system, the application programming interface that is present to other modules is independent of the particular user interface devices. As for example, we are taking radio buttons, dials, dialog boxes, etc. So they are having their own different things for interactions. Okay, na? But we can represent them with different types of shapes. Okay, now like this they can be independent on a particular users, how they are going to design the particular devices, interface devices also. Okay, that it uses a present information to the human user, because those might change. To domain here is to repartize to such devices. The module is process scheduler that hides the number of available processors, okay, and the schedule algorithms. The domain here is process scheduling and the list of appropriate algorithms. So we can also think different types of schedulings also here, how to we can perform the systems, how the process can be going to executed, everything is going under the consideration, they are going to develop the particular architecture. That's why we require the teams. That's why they are forming the teams. So what the teams doing? Creating a skeletal systems. First direct main system ni develop cheyaru a team kuda. First they are creating one skeletal system. So skeletal system means what ma, oka dupe, like skeletal means it is a blueprint for coming up, okay na. So that is called skeletal system. So once they decided, once they are taken ADD method, like this they are decided to design the structure like this by following these steps. So in these steps they are concentrating on some use. Then they are assign these things to the particular development team. So this team is decided how they are going to communicate, how they are going to share the ideas or design decisions together. So everything is over. So advantage and disadvantage like this we are going to do or not. So what are the benefits or not? After this they are directly they are not entering into the developing main system. First they are develop one skeletal system. So that is a blueprint or dupe system. Okay now, that is once the architecture is sufficiently designed and teams are in place to being building to it. Okay, so a skeletal system can be constructed first after taken the decision to design sufficiently. The teams are in place to begin building to it. Okay na. So in this scenario when they are going to take the step to building this particular architecture, first they are construct one skeletal system. The idea at this stage is to provide an underlying capability to implement systems functionality in an order the advantages to the projects. That is the very important to implement the systems functionality, and this is gives an advantages to the particular projects. So classical software engineering practice recommends subbidding out sections of code to be portions of the system can be added separately and tested independently. So whatever the thing they are taken, subbidding out mean is nothing but every portion is mainly focusing very carefully and separately they are going to be tested. Okay na. Independently means separately means independently they are going to be tested. Okay, that is a very important. However, with portions should be submitted by using the architecture as a guide, a sequence of implementation becomes clear. So why? Because the architecture is a guide. Okay na. We want to develop other architectures. This architecture is given the guidelines to them. Okay na. That's why they are focusing independently together. Okay na. While maintaining the skeletal system also. And first implement the software that deals with the execution and interaction of architectural components. ఒక సాఫ్ట్వేర్ మనకు మనం కన్సిడర్ చేసినట్లయితే ఇట్స్ మెయిన్లీ ఫోకసింగ్ ఆన్ ఎగ్జిక్యూషన్ అండ్ హౌ దే ఆర్ ఇంటర్ఫేసింగ్ టుగెదర్. So this execution and interfacing is done by whom? They are taking some components, those are called architectural components. First they can focusing on architectural components for interfacing and execution, and this may require producing scheduler in a real time system, implementing the rule engine, and so to control rule firing in a rule based systems, Implementing process synchronization mechanisms in a multi-process systems are implementing client server according in a client server systems. So while they are going to develop, they are thinking about, okay, now this is a multi-process system or multitasking system. They are going to perform in the client server system. So multiple actions is going to be established in a, they want to establish a particular architecture. They need to consider these types of communications are providing in this particular architecture or not. So based on this, according to their project, they are going to facilitate providing these particular types of processes. Okay, now that is the main thing of why they are first create the skeletal system, build a skeletal system. Often, the basic interaction mechanisms is provided by third party middlewares. Definitely, once they are going to design or develop a software architectures, definitely the third party will be take place here. So, no, not only vendor, not only client. Here, the third party will be also take place here. That is called middleware, we can call it as. Okay, in which case the job becomes once of installation instead of implementation. So, on top of this communication or interaction infrastructure, you may wish to install the simplest of functions, one that does little more than integrate some rote behavior. Okay, at this point we will have running system that especially sits there and hums to itself. But running system, nonetheless, this is foundation onto the useful functionality can be added. Like this, we can they can choose multiple options. So they can according to the skeletal system is going to be properly designed. How you can now choose which of the element providing functionality should be added to the system. The choice may be based on lowering risk by addressing the most problematic areas first. So first, while they are designing the skeletal system, first they are observing which area we are getting different more abstracts. So based on the particular area they are concentrating on, they can be according to that they will be resolve the problems. Like this they are going to design the skeletal systems, or it may be based on the levels and types of staffing available. Okay, or it may be based on getting something useful to market as quickly as possible. So, so according to that, while they are maintaining skeletal and build the skeletal system, they can be concentration on which area we will get most problems, as well as they can concentrating on marketing side also. How quickly we will design the system. So we can consider according to the architecture. They will be also considered according to the marketing side. Okay, and based on this they will develop the skeletal system. How fast we can build the systems before they can develop skeletal systems. Once the elements providing the next increment of functionality have been chosen, you may employ the users structure to tell you what additional software should be running correctly in the system. Okay, now why they, what is the another advantage? So we are developing this skeletal system, we will be understood functionality has been chosen, and also we can employ on the particular structure. Automatically we are having additional advantages. So how the system is going to be running correctly or not. So that is the main thing here, as that is the meaning of as opposed to just being there is in the form of a stub to support the functionality. Next point, this process continues, growing large and large increments of the system until it is all in place. So every time these checkings, these updations are going on in each and every stage. Okay, now that is the meaning of going large and large increments. Okay, now architecture is not to stop at one place. Okay, now today we are getting one architecture. Tomorrow with new features, with updation of new features, we are getting the new architectures related to the existing one. So this that is the going to increment day by day. That is the thing here we can. Okay, it is a continuation process. So that's why they need to take good decisions. They need to take the good decisions based on they will construct or build the good architecture. That's why they need to, before constructing the original architecture or build the original architecture, they need to build or construct the skeletal system. While constructing the skeletal system, they will be observe all those points. Okay na. So that at no point is the integration and testing task overwhelming. At every increment it is easy to find the source of newly introduced faults. So every new thing what will be tells us already existing faults manaki cheptundi, then we are going to update the things. So that is the very importance of why they are building constructing the skeletal system. Budgets and schedules are more predictable with smaller increments, which also provide management and marketing with more delivery options. The evaluatory delivery life cycle is the basis for the strategy that Microsoft uses. In Microsoft's version for this approach, a complete skeletal system is created early in a product's life cycle and a working but low friendly version is rebuilt at the frequent periods, often nightly. Okay na. Some large systems aithe they are going to take the skeletal systems, so they need to complete according to the approaches. So they need to concern different types of versions according to consideration of working of the particular life cycle. But so for example, small systems anukondi, they will be developed oftenly night. ఒక నైట్లోనే వాళ్ళు డిజైన్ చేసేసేస్తారు ఒకవేళ స్మాల్ సిస్టమ్స్ అయితే. బట్ దిస్ ఈస్ గోయింగ్ టు ద ఆర్కిటెక్చర్స్ ఆర్ గోయింగ్ టు ఇంక్రీజ్ డే బై డే. దట్స్ వై దే నీడ్ టు ఫోకస్ ఆన్ mainly working on the particular architectures. That's why every architecture has its own life cycle, as we said previous. So according to that, they need to complete the particular skeletal systems first. This results in a working system for which is the future can. This what is the result of this skeletal system? So this skeletal systems gives the what is the future expectations, what is the future to the particular architecture at any time be judged sufficient. Okay na. And the product rolled out. One problem to guard against, however, is that the first development team to complete a portion of the system gets to define the interface to which all subsequent subsystems must conform. Okay, now, according to this, they also maintain the interaction of the particular subsystems. So that is the very importance of the why they are forming the team structures. So while forming the team structures, what is the main thing they are going to be developed? Okay, na? So today we are I explained about so how to forming the team structures. So what is the importance to forming the team structures? So what is the role is taken by the team structures? So after taking the role or decisions by the team structures, what they are doing? They are preparing skeletal systems. Why they are creating skeletal systems? Why they are constructing the skeletal systems? So what is the importance of these skeletal systems before going to develop the original uh, uh, construction of software architecture? So I hope all you understood the importance of team, why they are forming the teams, and also what is the importance of skeletal system. Okay, thank you, Vananda. Stay live. I will take attendance.